we'll begin. It says they will cover two-dimensional structures. So far we've covered vectors and lists. Those were one-dimensional structures, and now we will get into two-dimensional structures. And then we'll get into some subsetting here as well. All right. Okay, so let's talk about matrices. Matrices are basically atomic vectors. Okay, so what does it mean for a vector to be atomic? It means that everything in that vector has to be of the same type. So in a matrix, everything has to be of the same type. If you have numbers in your matrix, then everything has to be a number. You can't combine character values into a matrix. What would happen if you replace, let's say we have this matrix, 1, 2, 3, 4, 5, 6, and let's say I replace this number 3 with the letter A. What would happen to my matrix? Yeah. Yeah, the entire matrix would be coerced into a character matrix, okay? And you would have a matrix of character values. It would become the character 1, character 2, the letter character A, character 4, character 5, and so on and so forth, okay? What distinguishes a matrix from an atomic vector is that a matrix comes with dimensions, okay? So effectively, this matrix is just the vector 1 through 6, but it carries the dimensions 2 rows, 3 columns. So let me just clear all this out here. Okay, so here I can say A is going to be the matrix of the values 1 through 6, and we're going to say n row equals 2, and I could just do that, and that will produce the matrix. Okay. So again, if I were to replace the third element in A with the letter D here, whoops, and we ask what happens to A, now we have everything has been coerced to a character. Yes, question.
It's kind of like blocked off.
Oh, it's blocked off. Okay, thank you. We will make sure it's not blocked off then. Okay, better. Okay, so that's what we have there. Let's go back and just kind of reset the A matrix there. If I ask type of A, what will type of A be? So I've just recreated my A matrix. Type of A is integer, okay? 1 through 6 is an integer vector. That's what we have, okay? The dimensions of A are that we have 2 rows, 3 columns. And if I ask what are the attributes of A, it will say you only have one attribute, which is the dimensions, and that's 2 through 3. Okay. So how is if I create a vector B of just the values 1 through 6, and ask what are the attributes of B? What will I get when I get back the attributes of B? It's going to tell me that there aren't any attributes, right? Okay, so B is just this character vector, not character, integer vector, 1 through 6. If I say type of B, it will say it's an integer vector, okay? Now, how can I assign attributes of B? I can do attr of B, and we're going to take the attributes dim, and we're going to just give it the vector 2, 3, okay? And so now the attributes of B, I have dimensional attributes. And what would B look like now that I print it out? It's now a matrix. Okay. So A and B are now the same. Okay, so B, I started off with a vector, I gave it some dimensional attributes, and now B is a matrix. Okay. And I could say identical A and B, and they are exactly the same. So creating a matrix using the kind of this matrix command, and then creating a matrix by taking the values 1 through 6 and then giving it dimensions, produce the same thing. Okay. So a matrix, so the key thing here of all of this stuff is that the matrix itself is an atomic vector, and it's just an atomic vector that has the attributes dimensions. So if we ask is atomic, the matrix is atomic. Okay. Is vector, what will this return? It's false. It's not a vector. Vector means it's one-dimensional. Okay. I guess what I can do is I'll maybe at the end of each class I'll copy and paste my console into another text file. Okay, so that's what we have for matrices. An array is basically if you have more than 2 dimensions, then you get an array. But it's the exact same thing. So here I've got a vector of length 12, 1 through 12, and I'm giving it 3 dimensions. So this is pretty much like, I don't know, a block, a parallelepiped, is that what we call it? Or a rectangular prism. You can have you now have layers or sheets stacked on top of each other. And we can see, 1 comma gives me this, and comma 1 will give me this first column, and then comma 1 will give me kind of the first layer, or comma 2 will give me the second layer over here. So, but an array is an atomic vector. An array is much like a matrix, except you have more than 2 dimensions. You can have 4-dimensional arrays, 5-dimensional arrays, however many arrays that are necessary. I think I showed you this already. We created a vector with the numbers 1 through 6, and then we modified the vector by changing the dimension attribute using dim_c. I think I also did attr of object C, and then you give it the values 3, 2, and then that produces a matrix. Okay. If you take C and you just say I want to change the dimensions to be 2, 3, then that means you have 2 rows of 3 columns, and it reshapes the matrix accordingly. Okay. The way R fills out the matrix is it fills it out by columns. So you take the values 1 through 6, and it will fill down the first column 1, 2, 3, and then the second column 4, 5, 6. When you reshape it so that it's 2 rows and 3 columns, it basically just treats this as, again, a one-dimensional vector going 1, 2, 3, 4, 5, 6, and then it takes that and it feeds it into this 1, 2, 3, 4, 5, 6, something like this. Okay. Instead of having the length of a vector, so when you had a one-dimensional structure, you created the, you can look up how many elements were in that vector by using length. We have n row and n column for matrices, or dim. Dim also works for matrices as well. Does length work for a matrix? And the answer to that is yes. Okay, so here A is this. If I ask the number of rows of A, what will it return? 2. It will return the value 2. And if I ask the number of columns of A, it will return the value 3. And if I ask the length of A, what will it return? It will return 6. It will return kind of the length of the an underlying atomic vector, which it is of itself, or not, but it's not a vector, it's a matrix. So you have that. You can also give it row names and column names, right? So right now, if we ask for the attributes of A, there's only dimensions, but I could say, you know what, I want row names and I want column names. So I'm going to say row names of A. I'm going to give it the character values capital A and capital B. Okay, and if I ask to print out A, it now looks like this. Now if I ask for the attributes of A, it now carries the dimensions 2, 3, and then it also carries dim names, which will have the row names and the column names. I haven't given any column names, so it says null now. If I change that and I say we want to give it some column names, lowercase a, lowercase b, and lowercase c, then we have exactly what I have right here. And I can ask what are the attributes of A, and now I have the dimensions, and then I also have dimension names. Okay, which is of itself a list. Okay, and I think we looked at this. And if we do the same thing with an array, the overall length of the array is 12, whereas if we ask the dimensions of B, this is for an array, it would tell me that you have 2 in the first dimension, 3 in the second dimension, and 2 in the third dimension. Okay, and then the dim names of B, basically, we are providing it a list here. So B is going to be an array of 1 through 12 with the dimensions 2, 3, 2. So here's B, and if I ask for the attributes of B, it gives me just the dimensions here. But if I want to start creating names, then I can do dim names of B, and then I would have to provide it a list, okay? A list of everything in it, so that the first dimension, I don't feel like retyping this. The first dimension have the names 1, 2. The second dimension have the names little a, b, and c, and then the third dimension has the names capital A and capital B. Okay, and it creates them as such. So the names of a matrix are stored in a list within the attributes. So if I ask for the attributes of, so going back to matrix A, if I ask for the attributes of A, and I ask for what is the structure of this thing, the attributes themselves is a list of 2, the dimensions and the dimension names, and the dimension names itself here is a list of 2, 1 for each dimension. Okay? For an array, if we ask for the structure of the attributes of B, it would still be a list of 2, dimension and dimension names, but the dimension names would have 3 things, 1 for each dimension in B. Is that okay? All right, if we can combine matrices and arrays, so just like you have the combine function C that allows you to kind of stick vectors together, you can do the same thing with matrices, except now you have binding. You can bind by column or bind by row. The slide truncates what happens here, but here I have A. If I bind by column, A and A together, it kind of just sticks these 2 together here. And if I bind by row, R bind, A and A, it sticks them together on top of each other. Okay. We could ask, we can store this thing as D, and then if I ask for the dimensions of D, it will tell me you got 4 rows, 3 columns. And if I ask for the dim names of D, it will tell me in the first dimension, the rows, you have capital A, capital B, capital A, capital B, and then for the columns, lowercase a, b, and c. You could have a one-dimensional matrix or an array. All right, so these are matrices with a single row or a single an array with a single dimension. But they are. But that's what we have. Okay, so here. F is just a vector, 1, 2, 3. If we ask for the structure of F, it will tell me it's integer with a length of 3. It has no attributes, and it is atomic. Okay. On the other hand, here I've got a matrix of the values 1, 2, 3. I'm going to put it all in one column, and we can see that the structure here there's only one dimension here. And here there are 2 dimensions, okay? And the attributes here is that the dimensions are 3 rows, 1 column. And is atomic here will return true. If we did it with a row, we get something very similar, except it prints out as a row. And we can tell it's a matrix in the output, and not a vector, because we kind of get the headings that indicate that it's a matrix, right? Okay, and then as far as the array goes, it prints out a little bit unusual here, but it will, when we ask for the structure of this thing, here I only give it kind of one dimension. It will say kind of just of one dimension. 1 through 3 of one dimension. All right. So that covers matrices, and now we'll talk about data frames. Okay. Data frame is a very common way of storing data in R, and the key difference between a data frame and a matrix is that in a matrix, everything has to be of the same type. It's atomic, right? That's kind of the defining property of a matrix, is that it is atomic and it has 2 dimensions. Well, the data frame, you've got a 2-dimensional structure, except the underlying thing is a list, which allows for different data types. So you can have one column be numbers, one column be characters, and each column will behave as numbers or characters or whatever it is that it is. It doesn't coerce everything to be of the same type. Okay? So underneath the data frame, it's stored as a list. Okay? And it's just that in this list, all of each kind of item in the list would be a vector, and each vector is of the same length. A lot of these things that work in the 2-dimensional structure for a matrix also work for data frames. So we have names, we have column names, we have row names. Okay, and but length is going to give us the length of the underlying list. So whereas when you ask for length of an atomic vector, if you had 4 rows and 6 columns, length would return 24. It would tell you how many elements are in that. I'm sorry. If you had a matrix with 4 rows and 6 columns and you ask for length of the matrix, it would tell you how many elements are in that underlying structure. There would be 24 elements. If you have a data frame with 4 rows and 6 columns, that data frame is stored in R as a list of 6 items. Each of those items have 4 elements in it. So if you ask for the length of a data frame, it will return 6 because the underlying list has 6 elements, or 6 elements in it, or objects. Okay, but number of rows will return back the number of rows. because a data frame is a list, you are able to subset it as if it were a list, or you could subset it as if it were a two-dimensional structure. That's kind of the nice thing about a data frame. Okay, so let's create a data frame here. So here I've got df is equal to data.frame. We're going to say x is 1 through 3, and y is the letters A, B, and C. So we'll just create a data frame, data.frame, x is 1 through 3, and y is A, B, and C. Okay, so if I ask for a data frame to print out, it prints out like this. And if we ask for the structure of df, it gives me x, and it says 3 observations of 2 variables. Okay, what would happen if I say type of df? The type of here is list. Okay, type of kind of tells you how it's being stored in R, the underlying thing. The class of the data frame is a data frame. Okay, so the class tells us kind of how R is going to output it onto the screen and how it handles a bunch of stuff. But the underlying thing is that the type of is a data the type of a data frame is a list. Okay. The default behavior of a data frame is that it will turn character data or string data into factors. Okay, so when we looked at the structure of the data frame, it does say we've got integers 1, 2, 3 for x, and then y has been turned into factors with levels A, B, and C. And we can see that the values that are actually being stored are those integer values, because factors are integer vectors are being stored as 1, 2, and 3. Okay, even though it appears this way. If we want to avoid that, we would have to, in the creation of data frame, we would set strings as factors equal to false. And if we do that, then we get this. It looks almost exactly the same, but when we ask for the structure of the data frame, we can see it's got x as an integer, and y is no longer a factor, but y is character data with the characters A, B, and C. Okay, it's a subtle difference, but you know, oftentimes factors might behave different from what we anticipated. Okay, factors are useful again if you have categorical data, but if it is character data that is not categorical, you should treat it as character data and not as a factor. So that's so you know, if you're recording I don't know, the brand of a vehicle, sure, that's a categorical variable. You can store it as a factor, okay? But if you're dealing with, you know, you're pulling in tweets online and you have the character strings, those are not categorical variables. That's character data, and it needs to be treated as character data. Okay, so this is same thing, rather than turning the characters into factors, we leave them as character data here. Okay, we can check to see if something is a data frame by using class, or you can also use the question is.data.frame, and that will return true. Things can get coerced into data frames using as.dataFrame. A vector will create a one-column data frame. A list will create one column for each element, but it's going to error out if you try to turn a list where the each element in the list is not of the same length. Okay. And then a matrix will go directly to a data frame with the same number of columns and rows. Let me see if we have kind of examples of this. Right. So if L, I could create a list where A is going to be the values 1 through 4, and B is going to be the first 4 letters of the alphabet. So here L is a list, and then I can do as.data frame of L, and it produces what I would expect. Okay. However, if I didn't have things of the same length, so A has 5 values, but B only has 4 in it, okay? So as a list, this is no problem. You can have elements of different length in a list. You can have 5 over here and 4 over here. That's not a problem for a list, but if we tried to turn this into a data frame, it's going to say the number of arguments imply differing number of rows. The first one has 5 elements, and the second one only has 4. It can't create a data frame here. Okay, so it's going to complain. Let's see. A is, here's my matrix, right? So again, if I ask what is the class of A, it's a matrix, and I can do as.data.frame of A, and now it almost looks the same, right? So if I say type of A, and then, but if I change this, and we're going to store this as the output J, and I say, what is J? It almost looks the same here, but if I say type of J, it's going to say list, and if I ask for the structure of J, it tells me it's a data frame. The structure of A is that it is a matrix, okay? So even though the output of A and what J are look almost the same, you can't tell them apart. If you're just looking at the console output, you can't tell if this is a matrix with named rows and columns or if it's a data frame. Okay, it's not possible to tell. You have to look at the structure of the underlying object to see, okay? Or the attributes. Attributes of A, we've got this. The attributes of J, we have this, okay? So what's the difference here is that for a matrix with names, the attributes are dimensions and dim names. The attributes for a data frame is that there's no dimension attribute, okay? The dimension attribute is figured out by how long the names and row names are for the data frame, okay? And then over here, the class is there, the data frame. Okay, dimensions of A will return that, dimensions of J will return the same. Okay, but they look similar, but they are different. Okay, we got it. So I don't know. Do you remember with A, I changed the third element to I don't know, a character, and then that coerced the whole thing. If with J, I can't subset it to the third thing. I would actually have to do 3-1, and I can change it to D like this. Oops, that's not what I meant to do. Yeah, that's all right. I meant to change this one, but I should have done, I don't know what I was doing, 1, 2. Well, anyway, I put this in here, and then it filled out the rest for me. It said we don't have values for B and C. And if we look at the structure of J now, what will the structure of J be? It coerced only the first column into characters. Okay. You can use cbind and rbind, much like we did with matrices. You can do the same thing with data frames. Okay, so if we take cbind of a data frame, we can do this. And here I'm binding df is kind of these first two columns, X and Y, 1, 2, 3, ABC, with a another data frame that says Z is 3, 2, 1. That's fine. If I want to take our data frame DF, which are these values, and then add a row to it, I can do that, and I have to say we're going to add the data frame where X is equal to 10 and Y is equal to the letter Z. When we do this, there are a few rules in that when you're combining column-wise, the number of rows must match. Row names don't matter, okay? When combining row-wise, the number and names of the columns must match. So here I'm combining, our data frame X and data frame DF have the columns X and Y. I've got two columns, one is named X and one is named Y. The thing that I'm going to bind to it needs to be a data frame with two elements in it, and they need to have the names X and Y. Otherwise, it's going to throw back an error. Okay. Sometimes we want to create a data frame by using cbind on vectors, okay? But that's not going to work. And the reason why it's not going to work is because cbind's default behavior is to create a matrix. And if you bind vectors of different types, because it's going to be a matrix, it's going to coerce everything to the least restrictive type. So oftentimes you bind things of different things and they become all character data, okay? Just do it directly and just throw it into data.frame, okay? And data.frame allows it to preserve the different natures of the data types. So here, if I did cbind A and B, what it first does, it's going to create a matrix of characters with 1, 2, and A and B. And then when I throw it into data.frame, it coerces everything into, turns everything into factors because it's looking at character data. And so it's got a factor with two levels, one and 2, and then factors with two levels, A and B. Okay. Instead, just go directly to data.frame. A is 1, 2, and B is A and B, and then that will preserve that it's an integer, and then if you include strings as factors, it'll leave it as character data, or it might turn it into a factor. It's fine, but just go directly to data.frame. Don't try to cbind things before going into a data frame. Okay, but if you have a data frame, you can just bind another column to it. Okay, this is a very common operation. Okay, taking a data frame and then just appending another column. This is a common operation, but I think because this operation is so common, students make the mistake of trying to do this. Okay. I guess if you really like using cbind, just start off with a data frame of one column, and then use cbind, and then keep adding columns to that, and it will stay as a data frame if you want to do that. Later on, we'll cover the package dplyr. Dplyr is an excellent package that I highly recommend. Dplyr uses something called a tibble, okay, and or a TBL. You can look up. Is it spelled tibble? I don't know. So this is, yeah, so I guess TBL_DF. We've got Tibble. It comes with a package Tibble. This does a few nice things. It's basically a data frame, except it defaults to strings as factors equals false. So it doesn't try to turn your things into factors. It also just prints out what is necessary to fit on the screen. So I don't know if you notice, but if you have something like empty cars, actually empty cars I think is a wait, empty cars, let me just check. Yeah, empty cars is a data frame. And so if you have a big data frame, it will put stuff up on this. It'll just try to print out the whole thing, and it kind of often overflows what you have on your screen. Library, we'll load up library deployer, and is it as dot tibble, as underscore tibble, empty cars. Then this is what happens. If it's a tibble, it only prints what fits on the screen. It'll only kind of print the first 10 rows rather than trying to print all of them. And then the columns that don't fit, it will just say, with 22 more rows and with one more variable. And the variable left off was carb, I think, carburetor. And then it leaves all these things off. One thing about tibbles, though, is that it doesn't let you have row names, okay? So with data frames, you can have row names, and tibbles don't allow for row names. So if you want to preserve the row names, you've got to take that. Like if I wanted to create, now I'm getting sidetracked here, but if I wanted to preserve the row names in empty cars, right? So if I want these row names, the Honda models and stuff, the vehicle models like the Honda Civic or Toyota Corolla. I didn't know that such a thing existed. But I would need to go to attributes of empty cars, okay? And we would see the row names, and I would have to extract this thing and store it as a column in the data frame itself, if I wanted that. Okay, well anyway, that's tibbles. All right, we've got a few minutes left, and I think that's enough time to cover just some beginning stuff in subsetting, okay? Subsetting is the idea of taking a big table, a big data frame, or a big data structure, a big vector, matrix, whatever it might be, and then just focusing on a small portion of it. One element, one row, a few elements, something like that, okay? Subsetting is very powerful in R, but there's a lot to kind of learn. And the key, I would say, is take a look at str, the structure of whatever data thing that you're looking at, and that should give you an idea of how subsetting should be done. Okay, so we'll start off with subsetting in atomic vector. Here I've got the atomic vector x. X has the values 2.1, 4.2, 3.3, and 5.4. So you'll notice in the original vector, the values after the decimal go 1, 2, 3, 4. So we can kind of remember where these things were, their positions were in the original vector. Okay, so we'll start with a simple vector x that has been crafted so that, okay, so anyway. We'll have a question with the online poll. So if you want to go ahead and log into online poll now, we'll have this in a few minutes here. So, but I just want to give you a heads up so we're not scrambling to log in. Okay, but so if we're going to subset X, I think you guys are familiar with some of these basic operations. You could just do something like, so here, let me just kind of recreate this. Create this vector x here, and you can subset x by just saying I want the third element, or you can give it multiple values and you can say I want the third and first element, and it returns that. If you run the function order x, okay, it will tell you the order that you would need to put the elements in to go from least to greatest. So it says you're going to first do the first, then the third, then the second, then the fourth. And if you subset x on the order of x, it puts them in order from least to greatest. Okay. So subsetting x on the order of x is the same thing as sorting x. You can subset and use the same number more than once. So you can say, I want the first element and I want the first element again, and it will do that. It's got no problem doing that. And this could be a useful thing, especially if we're going to do some kind of lookup operation. And if you ever give it decimal values when you're trying to subset using kind of the index of these things, it just truncates them, right? So if you say, give me element 2.9, R is going to just see that, give me the second element, and it returns just the second element there. If you give it negative numbers, it will omit those things, right? So if you say, give me x minus the third and first elements, it will just return back the second and fourth element in x. Okay? But you can't mix negative and positive integers. So if you say, I want x, but I don't want the first and I want the second, R is confused and says, what is it? You want just the second one, or you want everything but not the first one? And it says, you can't do that. With logical vectors, it will return back the elements that correspond to true. So if x has 4 values in it, and if we say I want true, true, false, false, it's going to return back the first and second elements because we have a true in the first 2 positions, and then it doesn't return the third or fourth element here. Okay? And if you give it a logical condition, such as x is greater than 3, then what R will do is it says x greater than 3, this is false, true, true, true. So then it's going to just return back the elements for which this thing is true, and it will only return the values where x is indeed greater than 3. Okay. If the logical vector is shorter than the vector being subsetted, it gets recycled. Okay, so x subset true comma false will return back the first and the third elements, which is equivalent to saying I want true false true false. All right, a missing value in the index always returns a missing value on the output. So here I've got true, true, NA, false, okay? This will return back true, true, and then this doesn't even correspond to like the third element or fourth element or whatever. It's going to return back a missing, an NA, okay? And then it gets to the fourth, and then it runs out, okay? So it returns back NA. If you give it nothing, it's going to return back the entire vector. Right? And if you give it 0, it will return a 0-length vector. Okay? A 0-length vector is different from the null object. Okay? So you can think of a 0-length vector as a container. Like here, it's a container that's supposed to hold numeric values, or a container that's supposed to hold integer values or something, but that container is empty. Whereas the null object is basically just it's not even an empty container, it's just that thing doesn't exist. If the vector is named, we can also use character vectors to return elements with matching names. So here I'm going to take X and we're going to give it the names A, B, C, and D for each element. And then you can subset using the character names, D, C, and A. So, and it will return it in the order that you ask for the subset here. So you can subset a vector using the character names as well. And just like indices, you can, I mean, just like the integers, you can repeat the index, and you can ask for A multiple times, and it will return back the same element multiple times. The names are matched exactly. So if the name is ABC and the name is DEF, and you ask, I want the thing that's named A and I want the thing that's named D, it's going to say, I couldn't find it, and it will return back NAs. Okay, so here is kind of just a quick question, and we'll run our, oh, something is wrong. Maybe you guys are saved by, no, it looks okay. Okay, so I'm going to go ahead and just click quick poll. So if you go to onlinepoll.ucla.edu, I'm hoping you guys are logged in and you're ready to answer. The question is this. Let's say we've created the vector 1 through 10, and I'm subsetting A using this. What will I get back? That's the other one. So go back.
Check on this guy, right?
Mm-hmm.
Thank you.
All right. Okay, so go ahead and just answer that. When you're done answering that, you guys are dismissed, and